an independent analysis of European defense capabilities and strategic policy.
The operational saturation of the electromagnetic spectrum in the Baltic theater has precipitated a quiet but significant reversal in air defense procurement logic. For decades, the trajectory of short-range air defense has trended inexorably toward fire-and-forget systems. The priority has long been on autonomous infrared seekers that allow operators to seek cover immediately after launch. However, the decision by the Lithuanian Ministry of National Defense on January 2, 2026, to finalize a major acquisition of the RBS 70 next-generation system signals a deviation from this norm. By opting for a laser beam riding guidance mechanism over widespread infrared alternatives, Vilnius is not merely purchasing a weapon system. They are effectively acknowledging that the electromagnetic environment on the northeastern flank of NATO has become too hostile for reliant autonomous sensors. This procurement, valued at approximately 1.5 billion Swedish kroner, serves as a critical case study. It illustrates how electronic warfare concerns are reshaping material acquisition and reinforcing the industrial integration between Swedish defense manufacturers and Baltic end users. At the core of this acquisition lies a technical assessment regarding the survivability of seeker heads in high-intensity conflict. Traditional portable air defense systems rely heavily on infrared or ultraviolet homing. This is a technology that has seen diminishing returns against modern countermeasures. The proliferation of directed infrared countermeasures and advanced spectral flares has degraded the kill probability of autonomous missiles. In this context, and the Swedish design philosophy behind the RBS 70 system offers a distinct asymmetric advantage. Because the receiver is located at the rear of the missile and looks backward toward the firing unit, the system is inherently immune to radio frequency jamming and traditional thermal decoys. This technical characteristic suggests that military planners in the region are prioritizing probability of intercept in a jammed environment over the tactical convenience of fire-and-forget capabilities. This choice, however, introduces a distinct operational trade-off that shapes force structure and training requirements. Unlike autonomous systems, the laser beam riding architecture requires the operator to maintain visual line of sight and actively track the target until impact. This operator-in-the-loop requirement imposes a higher training burden on Lithuanian personnel. It exposes air defense crews to longer periods of vulnerability during the engagement sequence. The acceptance of this risk implies a doctrinal calculation. It suggests that the threat posed by electronic warfare suppression is greater than the tactical risk to the operator. It also suggests that the training pipeline provided by the Swedish Armed Forces and Saab dynamics will need to be deeply integrated with Lithuanian force generation cycles. This creates a long-term institutional dependency that extends beyond simple hardware delivery. The configuration of this procurement further illuminates the shift from static infrastructure defense to maneuver support. And the integration of these launchers onto joint light tactical vehicles transforms the system from a defensive position holder into a mobile short-range air defense asset. This mobility is critical for supporting mechanized infantry and armored units in the Suwalki Gap. This is a terrain where static assets are liable to be rapidly located and neutralized by artillery. From a systems engineering perspective, mounting the RBS 70 onto a vehicle platform mitigates some of the inherent immobility risks associated with the tripod-based variants. It allows for shoot and scoot tactics, which are essential when the operator must remain exposed during the flight time of the missile. Financially and industrially, this contract reinforces the position of the Swedish defense industrial base as the primary arsenal for Baltic security. The production of the Bolide missile at the Karlskoga facilities represents a shift from just-in-time manufacturing to a more robust surge capacity model. The war in Ukraine has demonstrated that consumption rates for air defense interceptors vastly outstrip peacetime production estimates. By standardizing on the RBS 70, Lithuania aligns its supply chain with a neighbor that possesses a secured domestic industrial base, rather than relying on extended transatlantic supply lines. This geographic proximity reduces logistical friction. Theoretically, it allows for faster replenishment in a crisis, a critical factor given the limited strategic depth of the Baltic states. The specific selection of the Bolide missile variant also reflects an adaptation to the evolving threat matrix, dominated by unmanned aerial systems. At the kinematic performance of the Bolide, with a speed exceeding Mach 2 and an effective altitude coverage of over 5,000 meters, provides a kinetic solution to the problem of loitering munitions and reconnaissance drones. These threats operate above the ceiling of traditional gun systems, but below the engagement envelope of medium-range batteries. The cost per engagement analysis suggests that using a laser-guided missile is more economically sustainable than expending high-end radar-guided interceptors against relatively inexpensive drones. Consequently, the RBS 70 acts as a cost-efficiency filter. It preserves the inventory of high-value systems like NASAMS or Patriot for cruise missiles and manned aircraft. Furthermore, this acquisition must be viewed through the lens of the Baltic Drone Wall Initiative. The requirement to integrate these kinetic effectors with a broader network of passive sensors and electronic detection systems creates a demand for open architecture software. The Swedish industry has historically emphasized modularity in command and control systems. The interoperability of the RBS 70 with existing NATO air surveillance networks is a prerequisite for its utility in a layered defense. The data link capabilities allow the fire unit to receive cueing from external radars. This partially mitigates the limitations of visual acquisition in poor weather conditions, although the final engagement remains dependent on the optical tracker. The transaction highlights a broader strategic alignment. Swedish technology is serving as the de facto standard for the region. And as Finland and Sweden integrate deeper into NATO structures, the interoperability of ammunition and maintenance procedures becomes a force multiplier. A shared stock of Bolide missiles across the Nordic-Baltic theater allows for lateral logistical support. Ammunition can be moved between national forces without the friction of incompatible interfaces. This level of standardization is a key objective of alliance logistics, yet it is rarely achieved due to protectionist industrial policies. The success of the RBS 70 in this market segment indicates that for the specific requirements of the northern flank, characterized by complex terrain, heavy electronic warfare, and short engagement windows, the specific Swedish engineering compromises are viewed as the optimal solution. Ultimately, but the revitalization of a laser-guided system in 2026 serves as a critique of the over-reliance on high-technology automation in modern warfare. It serves as a reminder that in the contest between sensors and countermeasures, simplicity and unjammable physics often retain high utility. The Lithuanian decision forces a re-evaluation of what constitutes modern capability. It suggests that resilience against disruption is becoming more valuable than theoretical autonomy. While the system imposes limitations regarding weather conditions and operator exposure, these are accepted as necessary costs to ensure that air defense assets can function, even when the radio frequency spectrum is effectively denied. This procurement is less about the introduction of a new weapon. It is about the hardening of the air defense architecture against the reality of near-peer electronic confrontation.